This video will serve as the first part of our photoelectric effect series, or the modern physics series. The photoelectric effect is a phenomena shown by light. It's a phenomena attached to light. Light has been divided into two types of behaviors depending on its wave nature and particle nature. These two are the broad divisions of different under which different phenomena are clubbed, like under wave nature, interference. We'll come to talk about interference in a different video. It's when light passes through a double slit or a slit. It is a interference phenomena. And in particle nature, photoelectric effect. These are one of the many phenomena. These are not the only ones. Photoelectric effect is a phenomena attached to the particle nature of light. Basically, photoelectric effect can be explained only when light is thought of as particles, as light is thought of as particles. That is the only way we can explain the photoelectric effect. Now, before we go to the photoelectric effect, let's talk about the particle nature of light. So, particle nature of light is, said the light is made up of numerous particles called photons. These photons are energy packets. Light is a form of energy, don't forget that. These are energy packets. Obviously light packets, and these are energy packets, photons, energy packets. So basically they have energy. These photons have energy and they travel at a speed. We're in the beginning stages of the particle nature of light. We are not going to discuss every property of the particle nature because we don't require right now every property for the description of the photoelectric effect. We'll surely describe as and when we need them. So photons are energy packets. They have energy E, which has been found through experiments to be equal to h nu. This is newest frequency. This is a better nu. So let's cancel this one. H nu, E equal to h nu, and this newest frequency, h is a Planck's constant. It has a not a big value, it's a very small value. It is a constant. Nu is the frequency, and E equals to h nu equals to h c by lambda. Lambda is a wavelength, because nu equals to c by lambda. From that, the second equation, and this is the energy of that photon. This is the energy of that photon. One photon, E equals to h nu, the energy of one photon. Now, there is a statement to the photoelectric effect. We are in a position, now that we know that there is a frequency, there is a wavelength, we are in a position to speak about the statement of the photoelectric effect. Read those lines carefully it says that on a metal surface, this is a metal surface, let's say this is a surface, just the surface, and this light falling from here light is coming from here. These are basically all the photons. Say there are 4 photons. Sorry, it's not clear from, just a minute. This is a metal surface, and from here there's a light source. Light source, and from here 4 photons. It's better to make it like that so that we don't mess up again. I don't mess up again. 4 photons fall on the metal surface, and for each photon there will only be 1 electron ejection. So basically there will be 4 electron ejections. These are the 4 electron ejections. The statement says that the wavelength should be sufficiently small. What is the formula? From the formula we see that it's h nu hc by lambda. So we see equals to this also, and if this lambda is small, this value becomes large for small lambda. The statement could also have been for sufficiently high frequency or sufficiently low wavelength. It's the same thing. If the frequency is high, the energy is high. If the wavelength is low, again the energy is high because it's inverse proportionality. This is low, the whole thing becomes high. So the wavelength has to be sufficiently low so that the energy is high, and when it hits, the electron is ejected out of it. The electron is ejected, it's just ejected. This is the energy required this is the energy which it completely gives to the electron, which is just on the surface, and this ejects. Now there will also be electrons which are towards the interior part, and those also get somehow this light, they also get hit by photons. So shall we get this in the next video? This is enough for this video. We'll get about what happens after it hits and from onwards, this part, in the next video.